Okay, so in the previous video of MGF and CGF, I was talking about how to derive moment generating function for Poisson distribution and moment generating function for cumulant generating function, CGF for Poisson distribution. Okay, CGF is nothing but log of MGF. Okay, MGF is MXT, so I have put whatever value I have obtained from MXT and have tried to solve it, and then I've got an equation of this format. Okay, so what this is what I should say here is I have lambda multiplied to all the powers of t. So there's something called as a definition KR, okay, which is called the rth cumulant. Rth cumulant. What that is coefficient of t power r by r factorial in kx of t. In the cumulant generating function, the CGF, coefficient of t power r by r factorial is the rth cumulant. Okay. Now, what are the coefficients? Can you observe what are the coefficients of t power 1? Just see here. Coefficient of t power 1 by 1 factorial is what? Lambda. Coefficient of t power 2 by 2 factorial is what? Lambda. Coefficient of t cube by 3 factorial is what? Lambda. In other words, coefficient of all cumulants is lambda only. I can write like this. Kr is equal to lambda for r is equal to 1, 2, 3 and so on. Okay. Why do you need to do such a hectic thing, ma'am? Why do we need to learn about MGF and CGF? If you ask me, in short, cumulants are nothing but the moments. Okay, cumulants are nothing but the CGF generates the moments. What that is just see here, K1 is nothing but the mean. Okay, what's the mean of Poisson distribution? It is lambda. Okay, K2 is nothing but mu2. What is mu2 that I have got? It is also lambda only. What's K3? K3 is also lambda only. K3 is nothing but mu3. The third moment, it is lambda. See, instead of deriving such huge things, if I know CGF and MGF, I can easily get the moments for any distribution. Okay. Now, coming to K4. K4 or mu4. Mu4, how I will get is, mu4 is nothing but K4 plus 3K squared. K2 squared. Okay. So this would be what? Lambda. K4 is anyways lambda plus 3 lambda squared. Okay. I can also derive the skewness and kurtosis coefficients, guys, because I have mu3 na. Beta 1 is what? Mu3 squared by mu2 cube. Beta 1 is what? Mu3 squared by mu2 cube. I have all the things here. Okay, lambda squared by lambda cube, which is nothing but 1 by lambda. Beta 1 is nothing but 1 by lambda. Beta 2 is what? Mu4 by mu2 squared or not? Okay. So mu4 is what? Lambda plus 3 lambda squared by lambda squared. I can simplify it or I can put it, okay, like this. So all these things I can get provided I have moments. Moments can be generated using the CGF. What is CGF? In CGF, the quotient of t power k by k factorial will give me the kth cumulant. Kth cumulant is nothing but the kth moment, because of which I need to know MGF and CGF. There's also probability generating function, guys, but then that is not out of the scope for BTech students. So I'm skipping it off. I'll talk about a problem on Poisson distribution. A manufacturer of quarter pins know that 5% of his product is defective. If he sells quarter pins in boxes of 100 and guarantees that not more than 10 pins will be defective, What's the approximate probability that the box will fail to meet the guaranteed quality? First thing is, any distribution I can use. Why should I go with Poisson? Just see here. He has said certain criteria. Just see, he has told about certain criteria. What that is uh, probability of success is what? He is asking me what's the probability that the box will fail to meet the guaranteed quality. If I get a defective pin, which is more than, if I get more than 10 pins in a box, then I am successful. Okay, probability of success. How will I do it? Probability of success small p will be nothing but probability of getting a defective pin, of getting a defective pin. Yes, getting a defective pin. Right. Now, what's that probability that's been given to me? 5%. Getting a defective pin is 5%, which is 0.05. Okay. Now, how many pins are there in the box? N is equal to 100. Now you see here, for binomial distribution, I can use binomial distribution only till 20, guys. If n is equal to 20, I can use. Why? If you ask me 100 C27 or 100 C28 or something like that, can I calculate? Practically, can I calculate? I can't calculate. So, binomial distribution manually, when I'm doing it manually, I'm restricting n to 20. Anything more than 20 will go to Poisson only because both are discrete. Okay. Now, n is 100. So, what would be NP, guys? NP should give me something sensible, right? 0.05. So, NP would be what? 5. 5. So, lambda is 5. I've got the averaging parameter lambda. I just need to see what has to be done. He is asking when the box will fail to meet the demands. Let us write first the binomial distribution formula. Okay, what that is e power minus lambda, lambda power r by r factorial. Now he is asking me, he is telling that at the most 10 pins will be defective, he is telling. But if I get more than 10, at least 11 pins if I get, then whatever quality he said is not guaranteed. So my question I will set like this. Probability, what question I have to solve, I will set like this. Probability of the box failing the demand, the box meeting the demand or meeting the guaranteed quality. Guaranteed quality will be when P of x is greater than 10. Okay. I can either calculate this because I can either calculate and just see here. I should start from 10 and go on till 100. I should calculate all the probabilities. Instead, I can use this formula. 1 minus P of x less than or equal to 10 would be easy for me provided I have a calculator. Okay. So what I will do is, this is nothing but 1 minus summation I will put. What that is r is equal to 0 to 10 I will be taking. You all know this formula, right? X greater than 10, 1 minus p, x less than or equal to 10. Okay. Yeah. So lambda is e power minus 5, 5 power x by x factorial. It starts from 0 and goes to 10. Okay. So I should be using a calculator or the geometric series for finite. That formula also I can use, guys. I don't say compulsorily you should use this one. This is r, I'm sorry, r and r factorial. R is equal to 0 to 10 e power minus 5 by 5 fact. Oh, no, by r fact. No, it is 5 power r by r factorial. Okay. So it would be geometric series. You can go ahead like that, or you can directly solve using a calculator. Okay. I suggest you to do this problem. Okay. How to handle the Poisson distribution? This is how I will handle it. When I will go from binomial to Poisson is when n exceeds 20, because I can't calculate more than 20 things. I mean, NC zeros and all when n is more than 20. Okay. When n is greater than 20, usually it's fixed in the standard books that when n greater than 20, you will shift to Poissons when you are doing manually, especially. Okay. Yeah, this is a standard Gupta and Kapoor problem. I suggest you to look into it because this is a favorite question for the examiner.